In this video, let us see how to write a C program to sort an array using bubble sort technique. The problem is read n integers, store them in an array, and sort the elements in the array using bubble sort algorithm. Sorting means take an unordered collection and make it an ordered one. For example, assume that we have got an array with elements 30, 10, 40, 5, and 20. After sorting, the array content will change to 5, 10, 20, 30, and 40. This is the sorted array in ascending order. Let us see the logic for bubble sort. Assume that our array contains 30, 10, 20, 5, and 40. So let us take the first element, compare it with the second element. If the first element is greater than the second element, swap the values. So here 30 is greater than 10, so swap. So now 10 will come first and 30 will come next. Next compare 30 and 40. So here 30 is less than 40, so no need to swap it. Next compare 40 and 5. 40 is greater than 5, so swap the values. Compare 40 and 20. 40 is larger than 20, so swap the values 20 and 40. So now after this process, 40 has come into actual position. So we are doing the sorting in ascending order. So 40 is the biggest element, it has reached the correct place. Again, we start from the beginning. 10 and 30, no need to swap. 30 and 5, that is bigger, so we need to swap the values. 5 and 30. Next, 30 and 20. 30 is bigger than 20, so swap. We will get 20 and 30. So after this set of operations, 30 is in the correct place. 30 is the second largest one. It is in the correct place. Again, start from the beginning. 10 and 5, interchange. 10 and 20, no need to interchange. Now, 20 is in the correct place. Again, start from the beginning. 5 and 10. 5 is less than 10, so no need to swap. 10 is in the correct position. Now, only one element is left. So 5 is also in the correct position. So after all these operations, we got an array in the sorted order. So let us see the logic. So this is the first cycle that we have performed. After the first cycle, 40 is in the correct position. So we repeat the same process again in the second cycle. And in the second cycle, 30 comes in the correct position. Again, repeat the same set of operations. Now 20 is in the correct position. And finally, in the last cycle, 5 is also in the correct position. Let us convert this logic into flowchart. So let us take a variable j to represent the array position or the index value. So j starts with 0. Now compare the value of the first cell and the second cell. So that means we are comparing with a of j and a of j plus 1. Since the value of j is 0, we are comparing a of 0 and a of 1. So if a of j greater than a of j plus 1, then interchange the values. Temp is equal to a of j is equal to a of j plus 1, and a of j plus 1 is equal to 10. So temp is just a variable, a third variable. Now we need to compare the values of 1 and 2. So that means we want to increment the value of j by 1. So j equal to j plus 1. If this condition is false, that means a of j is less than a of j plus 1. That means there is no need to interchange. We can just go to the next element. So that means go to j equal to j plus 1. Again, compare j and j plus 1. So that means this is a loop. So we need a termination condition here. So what is the termination condition? So j should, so in this case, we have got 5 elements and j should go up to 3. So for it is, assume that the value of the size of the array is n, then the last element, the index value of the last element is n minus 1. So the j should go only up to n minus 2. That means we can write the condition j less than n minus 1. So this is n minus 4 is n minus 1 should go up to 3. That means it should be less than n minus 1. If this condition is true, then we need to compare the two values and swap if necessary and go to the next element. If the values, if the condition is false, then there is no need to interchange. Just leave the elements in the place and go to the next element. So now once this condition becomes false, that means we have reached the end of this one. We have reached, j has reached up to n minus 1. So once j reaches n minus 1, there is no need to interchange it. So we need to start from the beginning. So we take this as a first cycle. So likewise, since we have got 5 elements in the array, we can go up to 4 cycles. So let us take another element, another variable to represent the cycle number. So I equal to 0. That means this is the first cycle. So first cycle is over. Once this condition becomes false, first cycle is over, we go to the next cycle. So go to the next cycle means we increment the value of I equal to I plus 1. So that means I becomes 1. It represents the second cycle. So second cycle again starts with the same operation. That means we have to restart the process from j equal to 0. So here again start with j equal to 0. So these operations are performed until j less than n minus 1. Once it becomes no, go to the third cycle. That means I equal to I plus 1. Again perform the same repeated operation. Once it becomes no, go to the fourth cycle like that. We need a termination condition here. The termination condition can be I less than. So here 5 elements are there. So we go up to 4 cycles. That means n minus 1. But you can see that since the last cycle there is only 1 element, so no need to do all these operations. We can stop by the third cycle. So that means I less than n minus 1. If the condition is true, repeat the operation. If the condition is no, that means we have sorted the entire array element. So this is the concept of bubble sort. Now let us complete the entire flowchart. First, we need to read the elements of the array. So start I equal to 0, read a of I, the first element, then go to the next element, I equal to I plus 1. Again read a of I, this time it is a of 1. Again I equal to I plus 1, read I. So the condition here is the condition here is I less than n. So we do not know the value of n. So first we have to read n. Then read the array elements. Once this condition becomes no, we have read all the array elements and then we can start the sorting process. Once this condition becomes true, we have sorted the entire array and then go to print the array. I equal to 0, I less than n. Print a of I equal to I plus 1. So once this condition becomes true, all the array elements have been printed, then go to stop. So this is the flowchart for sorting an array. Now let us convert this flowchart to program code. So So what hash include stdi.h void main open curly brace declare the variables. So int array has been declared as ARR of 10, comma n the size of the array. Array ARR, size of array n, I, j, and temp. So now go to the reading of the, first we have to read the size of the array elements. Size of the array. Printf, enter the size of the array. Scanf %t ampersand n. Now go for reading the array element. Printf, enter array elements. 4. So this is a loop. For I equal to 0, I less than n, I plus plus open curly brace. Read the array element. So printf element j plus 1. Scanf %t ampersand ARR of I. So the only operation inside the loop is reading. So we can close the for loop. So now go to the sorting part. Sorting part, I equal to 0, then I less than n minus 1. So this is part of a loop, outer loop. So I plus 1, I equal to I plus 1 here. So we can use a for loop here. For I equal to 0. For I equal to 0, I less than n minus 1, I plus plus. Open curly brace. Go to the S part. Inside the S part, there is again another loop. So we can write for j equal to 0, j equal to 0 here, j less than n minus 1, the condition, and the increment part is j plus plus. So go to the S part. Inside the S part, there is another condition, but this is part of a selection statement. So you can write if ARR of j greater than ARR of j plus 1, then go to the S part. Inside the S part, temp is equal to ARR of j. Next statement, ARR of j equal to ARR of j plus 1. Next it is ARR of j plus 1 is equal to temp. So j equal to j plus 1 we have already coded here. So this is the end of the inner loop. Sorry. Before that, this is the end of the if body. So we can close the if body here. In the no part, there is nothing. So no need to write the else. Next statement, it is j equal to j plus 1. We have already coded j plus plus here. And this is the end of the inner loop. So close the inner loop. So now go to the no part of here. No part, it is I equal to I plus 1. That we have already coded here. And this is the end of the outer loop. So we can close the curly brace here. So this is the sorting part. So now go to the printing part. So printf sorted array. Again, it is a loop for I equal to 0, I less than n, I plus plus. Printf %t, comma ARR of I. So this is the only statement here. Close the loop body and end of the program. So close the main function. This is the entire program for sorting an array. So here is a sample output. The size of the array has been given as 5 and entered the elements 30, 10, 45, and 20. So the program outputs the sorted array as 5, 10, 20, 30, and 40. So in this program, if you want to arrange the elements in descending order, so here, instead of checking the greater than condition, you can check the less than condition. If